All right, when we're looking at these terms, the variable that we use for term numbers of a sequence, that is n. We'll be using that a lot today. If we wanted to find the slope-intercept form of the equation of the line with these 2 points, we would have to first start by finding their slope. So if we subtract the y's and subtract the x's on the bottom, we end up with 3/5 for a slope. Okay, so now if you think of our y equals mx plus b, we now know our slope is 3/5. We still don't know what that y-intercept is, so we're going to have to choose a point. Let's say I picked -3, 4 as my point to plug in, then 4 substituted in for x, or sorry, y, and -3 substituted in for x. Now I'm down to one variable. I can just solve this for b. Four is really like 20/5. If I add 9/5 to both sides, I get b. So 29/5 is b. So that means in my equation now I have the slope, 3/5 x, and my y-intercept, 29/5. This would be our slope-intercept equation here. Next slide, come on. All right, here's our sequence. The next term would be 62, because each time we are adding 7. Okay, so if I took 55 and added 7, I would get 62. So since we're adding the same thing each time, this is called the constant difference. So we could continue on with the sequence, but what happened if I wanted to know the 200th term of the sequence? You certainly don't want to generate the next terms just to get one answer. I don't want to keep adding 7 and adding 7 all the way up until that 199th term, and then add 7 to find the 200th term. So if you knew a rule for calculating any term in a sequence without having to know the previous term, you could apply it to directly calculate the nth term. The rule that gives you the nth term for a sequence is called the function rule, right? And we already had our function review in the 2.0 notes, so we're talking more about function rules today. So if we wanted to find the rule for the sequence listed there, it would help us to place the terms and values in a table. Okay, so this hint says always start the term row with 1. You have your first term, second term, third term, fourth, fifth, and sixth. Okay, well here was our first term, 7. Our second term was 2. Our third term is -3, -8, -13, -18. Okay, so if I counted by 2's, that's what the graph would look like if I plotted these points. Now, if we look at the constant difference here, to go from 7 to 2, we have to subtract 5. Okay, we are subtracting 5 this whole time. If I pick any of these 2 points to find their slope, here my slope is -5. So this constant difference is the slope. Rules with a constant difference are linear functions. They keep the same slope the whole time, just like a line does. Okay, so now let's find the nth term. To do this, we need to find the slope-intercept form of the equation of this line. Well, we know the slope. Now we can pick any point to plug in there. Let's say I chose 1, 7 as my point. Oops, so now instead of y, I'm substituting in 7. For x, I'm substituting 1. When I add 5 to both sides, b is 12. So my function rule is the slope-intercept form here. I've got negative 5x plus 12. Okay, so you can find the value of any term in the sequence by substituting the term number for n in the function rule. Let's look at an example of how to find the 200th term in a geometric pattern. We will actually get to that tomorrow in class together.